So what we've been working on is the factoring refresher, right? Ooh, green. I didn't know what color I was starting with. And what we started with last week is we had those trinomials of the form ax squared plus bx plus c, that standard form. And we were really focusing on where a was 1. So all our problems were starting with x squared. I like to use a little chart that tells me what my factors are going to look like before I even get started. When everything I'm dealing with here is positive, I know that my factors are going to be an x plus something times an x plus something else, right? If I have ax squared minus bx plus c, so my x term is negative, but my c term is positive, we're going to have x minus something times x minus something else. If I have ax squared plus bx minus c, or ax squared minus bx minus c, my factors are going to look like x plus something times x minus something. In this case, this would be my bigger factor, right? The positive. In this case, this side would be my bigger factor. I mean, my negative factor, right? So what it's saying is if your B term is positive, your bigger factor is going to be the positive. In this case, where B is negative, your negative is going to be the bigger factor. And I'll show you how that plays out. We'll do examples of that. We already kind of did. And just to refresh your brain on what we're talking about here is we could start with, say we had x squared minus 15x plus 26. I think we actually did this one as an example. And in this case, our a value is 1, right? We're starting with just an x squared. So all we have to do is take the factors of this number that add up to this number. We're taking take factors of c term, take factors of c term that add to b. Right? So we're looking at what are our factors of 26 that will add to 15. And so this one's nice and easy because there's not a lot of factors of 26. We have 1 and 26, and we have 2 and 13, and that is all of the factors of 26. If I add 1 and 26, I get 27. If I add 2 and 13, I get 15. And we have a 15 here, so we know that those would be the factors. And we know by the fact that our 15 is negative, but our 26 is positive, that our factors are going to be x minus something times x minus something else. And then we can just plug in those numbers. And that's what we did earlier this week, right? We also talked about pulling out greatest common factors. We should always look for greatest common factors first. But today, what we're talking about is when our ax squared, when ax squared plus bx or minus bx or whatever, where a doesn't equal 1, right? Everything we've done up to this point, our a value was 1, which is how we were starting off with this x squared and nothing in front of it. And now we're going to talk about what happens when that a is no longer 1. And you guys probably throughout your years have been taught different tricks for doing these problems. I know some people use this X thing where they put the factors in here and the problems in there. I don't know how it works. If you know how to work that, go ahead and use that method. This is the method I like to use because it doesn't change much from the original method, what we're doing when it's 1. So if I have, for example, 2x squared minus 15x plus 18, what I like to do is I like to take this 2 and multiply it by 18 and then rewrite the problem as x squared minus 15x plus 36. And then I can take the factors of 36, just like I did before, right? So we know what our factors of this are going to look like. We're going to have an x minus something times an x minus something else. If you don't remember, just use the chart, right? That's okay, Jesus. And so now we're going to do it just like we had before. We're going to find the factors of 36 that add up to negative 15. They're both going to be negative, right? They would be negative 1 and negative 36, negative 2 and negative 18, negative 3 and negative 12, negative 4, negative 9, right? 4 times 9 equals 36, 3 times 12 equals 36, 2 times 18, 1 times 36. Next, we'd have negative 6 times negative 6. And that would be all of the factors, right? We've accounted for everything. Nothing else goes in there because the next one will be 8, doesn't go in. The next one after that would be 9, and we've already accounted for 9 over here. So we've found all of our factors. And now we just need to look at, well, which ones, if I add them together, will give me negative 15. Clearly, negative 1 and negative 36 won't do that. Minus 2 minus 18 is negative 20. Negative 3 minus 12 is negative 15. So this is our solution right here. These are the factors that work for us. We have negative 3 and negative 12. The only thing is now we're not finished. Yes, Kevin? You have a question?
Never mind. You can finish the equation. I was going to ask a question about it, but you should finish first.
Okay.
You might answer it. Ready?
So we're close to being finished, but we've multiplied this by 2. And so now we have to divide that 2 out of each piece before we can start. If it divides evenly, we're just going to write it as what it is, right? But if it doesn't, like 3 divided by 2 doesn't give us a whole number. So we're going to take that 2 and we're going to put it in front of the x. So this factor would become 2x minus 3. Here, 12 divided by 2 is just 6. So we have x minus 6. This is our solution right here. If we wanted to, we could check it, right? We could multiply these two things together and we could see that it's going to take us back to the original equation, right? If I multiplied 2x times x, I would get 2x squared. If I multiplied 2x times negative 6, I would get minus 12x. If I multiplied negative 3 times x, I'd get minus 3x. And if I multiply minus 3 times minus 6, I get positive 18, because negative times a negative is a positive. And then when we combine these like terms right here, we would have 2x squared minus 15x plus 18. And that should always work when we're dealing with factors, because all factors are what two things are multiplied together to make this original thing, right? If I'm looking at the factors of 6, I would go, well, I've got 1 times 6 and I've got 2 times 3, right? And if I multiply those things back together, they better give me 6 because that's the idea of factors. Well, that's the same when we're factoring trinomials. They're saying, how can we break these things down to things that are multiplied to each other to get the whole thing? Like, what can we divide evenly into these trinomials? And next week, we'll get into why we're actually doing it because it will help us to find the solutions. But does this make a little sense to you? We'll do more problems. You'll see more problems, so you don't have to get it all on this one. But yes, Kevin.
So basically, the only difference when there's numbers in front of it is you multiply it to C and then just divide it out if it don't fit.
Well, yeah, first you multiply it, right? And you solve it based on the multiplication, right? You rewrite it.
Yeah.
Right? Then you find those factors and then you have to divide that back out.
Okay, and you said that if it don't divide evenly, you just put it in front of the x?
Exactly. You put the denominator in front of the x.
So it's not really that much of a difference.
No, it's not. That's why I like this method of it, because you're solving them the same way, right? You just have to add it back in at the end.
Yeah, it makes sense.
Yeah. We'll do some more, though, so you can see it, so you're not just dealing with one solution. And we'll do different types of them so that they won't all be like minus, minus, or plus, plus. We'll do a variety of different problems, and then we'll do difference of squares, which is easy. Difference of squares is a cakewalk. So let's look at this example right here. If I have 5p squared, I hate it when the variable's p. I usually change it because I have to say p too much. Plus 22p minus 48. Oh man, I don't know why I picked this one, because now I got to multiply 5 times 48 and find all the variables there. But it's okay. We can do that. Find all the factors, sorry. So if I go 5 times negative 48, I'm going to rewrite this as p squared plus 22p minus 240. And so I'm going to look at my factors of 240, and there's probably a lot of them that are going to add up to 22. What I know is that one is going to be p plus something, and the other one is going to be p minus something. And I know this because my negative term is negative. And anytime our negative, our end term, sorry, not our negative term is always negative. Anytime our end term, our constant, we call it a constant because it doesn't have a variable attached to it. Anytime that is negative, we're going to have a positive factor and a negative factor. And the way we know which one is bigger is by this, right? If whatever's right here is positive, your bigger factor will be positive. If this was negative, your bigger factor would be negative. So I know that this would be like -1 times positive 240, -2 times 120, -3 times 80, -4 times 60, -5 times 5 is 24. How many times 4 with a 48? -6 times 40, -7, no, -8 times 30. That's the one that's going to work. I can already tell. So I'm going to stop coming up with factors of 240. Here's the thing. You don't have to make this table. You can go into a calculator and just see what goes in, right, to figure out your factors until you find one that works. I'm going to stop, though, because I'm only concerned with the ones that add up to 22. And once I find that one, which is right here, 30 minus 8 is 22, I know I found the factors that I need. And so in here, I'm going to write 8 on the negative side, right, and 22 on the positive side. Now we have to put that 5, that divide that 5 back out, right? So here I'd have 8 divided by 5, and here I'd have 22 divided by 5. That feels wrong to me. But it's what I got, right? That feels wrong though. Oh, 30. Sorry. That's because I wrote this wrong. I wrote 22 and I was supposed to write 30. I'm like, one of these has to divide evenly. They add to 22. The factors are -8 and 30. I just wrote the wrong factor in. That's all. These are my factors. So here, 30 divided by 5 is just 6. So I have P plus 6, right? Here, 8 does not divide evenly by 5. I can't reduce that fraction any further, right? So I'm going to take that 5 and I'm going to put it in front of the P. And I would wind up with 5P minus 8, right? This right here is our solution, right? These are our factors. I am not going to ask you to check it, but you can check it to see if it's right. You would have P times 5P, which would be 5P squared. And then you'd have P times -8, which is -8P. 6 times 5P, well, that's plus 30P. 6 times -8 is -48. And you can already see that we're working our way back to that original equation, right? When I combine -8P plus 30P, I wind up with plus 22P minus 48. And so we can tell that we got it right if we want to. Let's do one more and then we'll move into difference of squares. Yeah, Kevin?
That question.
I'm sorry?
Sorry, my mic cut out. Before you answer that question, how can you tell which side? You know how the left side is negative on the chart and the right side is positive? How do you tell which side is negative or positive?
I tell by, see where the 22P is? This term right here will determine which is negative and which is positive. If it's positive, your bigger factor is going to be positive. If it's negative, your bigger factor is going to be negative.
Oh, okay.
Right?
Oh, that's what you're talking about on the chart thingy before.
Yeah. So when you...
That makes sense.
So if you come up here, right, we've got the original chart of if your problem starts out looking like this, you know, positive, like anything with a negative end term, you're going to have a positive and negative factor. The way you tell is by whatever is in front of your non-squared variable, right? So your B term determines it. If it's negative, your bigger factor is negative. If it's positive, your bigger factor is positive. And if you think about it, it makes sense because you're adding these factors together to get that middle term, right?
Yeah.
And so if your bigger factor is negative, like if this was -48 plus 5, we would wind up with -43. So we would have a negative term.
Okay, thank you.
You're welcome. That's a good question. Let's see. Let's do one. I like this one because I like it. That's why. That's why I like it. If I have 12x squared plus 5x minus 2, again, we know that we're going to be left with a positive and a negative factor, but we're going to start still by multiplying that 12 times 2. And we're going to write this as x squared plus 5x minus 24. This is the one I messed up when I did the other day because I divided 2 back out instead of 12, but the thing I multiplied by was 12. So I just messed up. I don't know what was going on with my brain. So I know I'm going to have a factor. One is going to be x plus something. One is going to be x minus something because our end term is negative. And so we just need to find those factors of 24 that add up to 5 so we can figure out what it is. In this case, again, our bigger factor will be the positive one because we have a positive term in front of the x right here, right? This 5 is positive. So we know it'll be -1 times +24, and -2 times +12, and -3 times +8, -4 times +6, and -5 doesn't go into it, and then 6 is already accounted for right here. And so we're going to add these up and see which ones add to 5. 24 minus 1, well, that's 23. Doesn't work. 12 minus 2 is 10. Doesn't work. 8 minus 3 is 5. So that's what we're looking for. So these will be the factors we're going to use, right? And the -1 will get the 3, and the +1 will get the 8. And we aren't done yet, because now we have to divide that 12 back out. So here I've got 12, and here I've got 12. Now, I talked about if it divides evenly, we're going to move it. But we do have to reduce these fractions first to check that out. So this would be x plus, each of these are divisible by 4. We would get 3, 8 divided by 4, sorry, is 2. 12 divided by 4 is 3. So we have 2/3 right there. And here we have x minus, well, 1/4, right? These are each divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. After this, now that we've reduced the fraction, well, 2 doesn't divide evenly by 3, so we're going to move that 3 to the front. So we get 3x plus 2. Here, 1 doesn't divide evenly, 4 doesn't divide evenly into 1, so we're going to move that 4 to the front, and we would get 4x minus 1. These are our factors. If you leave it like this, that's fine for the most part, right? It's still accurate, but then any more work that you would have to do, you're going to have to do in fractions. And I know how you all feel about fractions. And so I think it's much easier to work in terms of this than it would be to deal with those fractions, right? So this is our solution. I am not going to test the solution this time. I know it works. I don't need to prove it to you people. I don't have to prove myself to you. That is the last example I'm going to give you of this. What we're going to talk about right now is the difference of squares. And difference of squares is easy once you understand the concept of it. And we're going to kind of throw that whole ax squared plus bx minus c out the window a little bit, because a and b are going to be a little different for us right now when we talk about difference of squares. Difference, anytime you see the word difference, we're talking about subtraction. There's key words in math sometimes. Difference is always subtraction. Sum is always addition. Product is multiplication. Quotient is division. But difference always deals with subtraction. And we're talking about the difference of squares. And what we're saying is that if we have something, this a squared, something that's perfectly squared minus something else that's perfectly squared, our factors will be the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. What does that mean? That means if I have x squared minus 4, that my factors will be whatever the square root of this is, right? X squared is just saying that we have x times itself, right? It's squared. Minus, well, 4 is 2 squared, right? So it's saying that our factors would be x plus 2 times x minus 2. If I had x squared minus 81, well, this is x squared, and this is 9 squared, right? And so our factors would be x plus 9 times x minus 9. Does it get more complicated than that? Heck yeah. Absolutely gets a little bit more complicated than that. But it still doesn't get difficult. If I have 9x squared minus 25 y to the fourth, right? If I look at this, this is 3x squared, right? If I look at this, well, 25, the square root of 25 is 5. Y to the fourth, well, that's y squared times y squared. You can always do that when you have these even numbers here, because that whole thing is just squared. It's 5y squared squared. So my factors would be 3x minus 5y squared times 3x plus 5y squared. Yes, Kevin.
So we just have to find those, and that's the answer?
Yeah.
Okay.
Yeah, it's like a special, it's a special product way of finding the factors when we've got a perfect square minus a perfect square. Does not work if it's a perfect square plus a perfect square. But anytime you have a perfect square minus another perfect square, you can use the difference of squares to factor them. What if I had something like m squared n squared minus 49, right? If we looked at this, we go, well, this is just m times n squared minus 7 squared. So we would have mn minus 7 times mn plus 7, right? The nice thing about these, really no work to show, right? You should kind of show this so that you could see that that you've got your perfect squares. Sometimes though, and this will be as complex as it gets, they'll try and trick you a little bit, right? You'll have something like 2a squared b minus 32a fourth to the fourth b, right? Well, remember, anytime we're dealing with stuff, we're looking for a greatest common factor first. And we can't do, oh, sorry, this is supposed to be 32. 32a to the fourth b. That would change things. If it was 3, it wouldn't work because 3 can never factor down to a perfect square. A to the fourth b. So I'm going to look at, well, what can I pull out of these right off the bat? Because any time that we're trying to factor, we're looking for a greatest common factor first. We talked about that earlier this week. These are both divisible by 2, right? So I can factor a 2 out of each of these. They each have at least 2 A's, right? This one has 2 A's, this one has 4 A's. So I can pull 2 A's out of there. And each of them have a B component. I can pull a squared out of there, and I can pull a B out, right? They each have a B. So if I factor the 2 out of this and the a squared and the b, I'm just left with 1. I've pulled everything there is to pull out of there, right? On that side. Minus, well, we've got 32 divided by 2. So let's look at that. That's going to be 16. Here I have 4 A's. I pulled out 2, so I'm going to have 2 left. And I am not going to have any B term at all, right? Because I already pulled that out. And so now what I'm factoring is this piece right here, right? I have 1 minus 16A squared. Well, 1 is just 1 squared, and this is just 4A squared. So Now I can write those factors. I have to bring this with me, but this is just going to be 1 minus 4a times 1 plus 4a. This will be as complex as it gets in terms of the factoring, but you just have to find a way to break them down a little bit, and you'll know if it's listed as a difference of squares on the worksheet, right? If you have a difference of something, think about factoring it out if they don't look like perfect squares right away. Think about looking for that greatest common factor like we did when I saw you guys on Tuesday. Any questions pertaining to any of that? So you guys are all going to be factoring rock stars. You're going to get this worksheet done. Good. All right. Your comments are looking good. I know sometimes it's hard to know what questions to ask until you've practiced the problems. So I totally get that. I'm going to stop the video now so I don't have to keep looking at myself on that screen.